Hello. So in this video, we're going to take a long look at how the state of Oklahoma determines state aid to public schools. Uh, as we work through the first part of our course, we're going to dissect this video and take time to work on various parts, but I want to give you a big overview. So you will see this video and then probably some other uh, videos as we do each little individual part. The thing to keep in mind as we go through this, we're going to talk about two different things here in addition to just looking at how state aid is figured. Uh, First of all, keep in mind that when Oklahoma and other states determine state aid for schools, we're paying schools or we're giving money to schools based on students. So everything has to be converted to students somehow. And so when we talk about a school being isolated, we somehow have to take that isolation and convert it to students. When we talk about teacher tenure and your faculty and how many degrees they have and how long they've been in the system or how long they've been teaching, we have to take that and convert that into students. So everything that we do, we're going to turn into students. Okay, that's how schools are paid, is by the number of students. And so we're going to convert those things to students. That may not make sense right now, but it will make sense after we go through this. The other thing is that we're going to talk about equity a lot here. Equity means that we're treating unequals unequally until they're equal. And by unequals here, we're talking about districts that don't have the ability to raise money on their own and are reliant upon state aid to help supplement what districts can raise on their own. So that's one form of equity that we're talking about, the horizontal equity, meaning across districts. So that if we have an extremely wealthy district as far as local tax base, and a very poor district as far as a local tax base, the formula will take that into consideration in determining how much state aid to give to each school. And the idea is that the district that's unable to generate enough money on its own is going to receive more money to help compensate for that lack of a tax base. So that's horizontal equity. The second type of equity is called vertical equity. And the main place we see this is going to be in classrooms and students in different grades. So those are two things that we will cover, the equity piece and converting everything to students so that districts can receive money. So let's begin. Now you have a couple of packets to download. This is the main one that you'll be using. This is the state aid formula sheet. And we're going to work through this and explain what all of these are. And we're going to actually put some data in here. So I would encourage you to actually input the data as we go through this presentation so you can have a hard copy. This is the dummy data that we will use, our demonstration data, and we're going to cover just about everything on this sheet and put it in that formula so that we can determine how much money this district is going to receive from the state. So let's get started. When we're looking at the state aid formula, at first glance it's very convoluted, but actually there are three distinct parts here. The first part is going to be what we call our foundation aid. And this is where we're going to see the horizontal equity come into play. And within this, what we want to do is look at a district's ability to generate money on its own and compare that to how much money the district is going to receive simply based on students. And we will obviously go into that in great detail. The second area is transportation aid. Keep in mind transportation is provided by almost every district in the state. It is not a requirement that you provide transportation. but you get money from the state for transportation based on the number of students a mile and a half away from the school. And then finally, the third area is what we call our salary incentive aid. And we will look at that as well and determine that. This is a little bit easier than the foundation aid. But we will do them all, and then we will add all three of them together, and that will be the total state aid for our district. So we have two factors that are important here, and these factors are given to us by the state every year. Once the state determines how much money the Department of Education has, then the Department of Education will calculate these new aids, and all the districts will know what these new aids are, and it's based on these aids that we distribute money. And we will go into this quite a bit later on in the first half of the semester. So for right now, for this demonstration, these are the numbers we're going to use. Okay, the foundation aid is $1,459. The incentive aid is $69.93. Keep in mind that when you actually do your calculations, you will use different numbers, and they are in your packets telling you which numbers to use for these two types of aid. So to begin with, we're going to look at our data sheet, and we want to know two things off of here: the total net valuation and the state dedicated funds. Now, the total net valuation deals with property taxes in your district. And so in this district, the total net valuation for property taxes is $4,118,446. And then we have something called the state dedicated funds at $270,543. And we're going to pull those off our data sheet, and we're going to insert them in our first page, our state aid sheet. So let me go back here and look at this. So when it says total net valuation, we're going to see three different names for the same number: the adjusted valuation, and the adjusted district assessed valuation, and the total net valuation are all three the same thing. So we simply put those numbers in. So there you can see our $4,118,000 at the top and at the bottom, and we're going to start carrying out our math. And so when we multiply that times 15 mills at the top, we come out with $61,776.69. Now let me explain real quickly what a mill is, because you see at the top and at the bottom we end up with a total of 35 mills. We have 15 mills in the foundation aid and 20 mills down in the salary incentive aid. A mill is 1/1000th of a dollar, and so this is how taxes are paid when it comes to property taxes. They're paid in mills, and it's the mill is assessed against the valuation of your property. And so if you look at your property taxes, it will tell you according to different education and municipalities how many mills of your property taxes go to each entity. And so in the foundation aid here, we have 15 mills going to the foundation aid. And so that's why we multiply times 0.015. That's turning 15 mills into a decimal. And that's how we get our 61,000. Now at the bottom, we're going to take our adjusted district assessed valuation, and we're actually going to divide this one by 1,000. Okay, and I'll explain to you later on why we did that, why we divided by 1,000. It has to do with the fact that we're talking about mills, but keep that in mind. Okay, so in part B at the bottom of the salary incentive aid, we divide 4.1 million by 1,000 and come up with $4,118.45. The next thing we're going to look at is back up at the top in the foundation aid, and this is our 75% of the county 4-mill levy. The county 4-mill levy is a carryover from history in Oklahoma. 4 mills used to go toward the upkeep and maintenance of the all-black schools in each county. Well, once school segregation was declared unconstitutional, instead of doing away with that 4-mill county levy, the counties or the state continued to keep it, and is simply now divided up among the school districts within the county. And so, again, the way we get that 4-mill levy is we multiply our adjusted valuation, in this case 4,118,146, by 4 mills, or 0.004, and we come out to the 16,473.78. So just keep that in mind how we do it, because that's an area that students will quite often forget. You multiply your adjusted valuation by 0.004. And then once we get that, we take 75% of that and give that to the school. And that comes out to $12,355.34. Okay, so that's your 4-mill county levy. And the last thing we're going to look at here at the top are what we call the state dedicated funds. These funds over to the left, as you can see, the school land funds, gross production dealing with gas and oil, motor vehicle collections, and the REA tax. REA stands for Rural Electrification Association. And these funds are given by the state to the districts, and these vary widely among the districts, just depending on what type of taxes are being collected. And probably the biggest one in here where we see a change is in the gross production tax. So districts that have little or no oil and natural gas have little or no gross production, and districts that have a tremendous amount have a huge gross production tax. But for our district, we have $270,543. Now, I talked about the idea of horizontal equity, making schools as equal as possible when compared to each other. So what these three things did here is it determined how much local money this school district was able to generate on its own through property taxes, the 4-mill county levy, and then the state dedicated funds. And so our next step then is to add these together. And so what we see then is this district is able to generate $344,675.03 on its own from local sources. So basically, in the concept of horizontal equity, if the district can generate that on its own, then we're going to subtract that from the money that the state would naturally give it. And so the district will get less from the state. So if the district is able to generate a tremendous amount, more than the state would actually give them, then what we will see is that they actually get nothing from the state. And there are a few of those districts in Oklahoma that are able to generate enough money locally that they don't receive money from the state. Most, by far, are not able to do that. And even though they can generate some locally on their own, they are going to take money from the state. But for now, know that when we see that phrase, their total chargeables, I think it's supposed to be chargeables, but this was actually taken from the State Department. It could be charables, I guess. But I've always heard it referred to as chargeables. The total chargeables then are what the district, again, can raise on its own, and we're going to take that away from the state. So now let's move down to transportation. This one is pretty straightforward. We need to come up with three numbers: our average daily haul, our per capita, and our transportation factor. And what we're going to see here is that really we have to figure out what our per capita is. The transportation factor is going to stay the same, and our average daily haul is just different for every district. So let's go to our information sheet, and we're going to pull a couple of numbers off of here. First of all, we see what our average daily haul is. It's 407 students. Now, we don't have our per capita on here, but we do have the size of our district, and our district is 291 square miles. So what we're going to do now to figure out our per capita is we're going to take the size of our district and go to the last page of your first handout, and that is this page. And you can see it says the per capita allowance shall be determined using the following chart. What it doesn't tell you is how to get it. Okay, so our goal is to figure out what our density figure is, and it's real easy to do. What we're going to do is take our average daily haul and our square miles, and we're going to divide them. So 407 divided by 291 equals 1.3986. And we simply find that on the chart, and there it is. And so now we know that our per capita allowance is $90. So we're going to get $90 per student. And then our transportation factor, as I said, is going to be 1.39. This one in theory can change every year, but it hasn't changed in a long time. So we now have our three transportation numbers. 407 students hauled daily at $90 per capita because we divide our average daily haul by 291, size of our district, and then multiply all that times our transportation factor, and we come out with $50,915.70. And we're going to plug that into our formula. Okay? So moving on. Now, the next step is what's probably going to take you the longest, and that is figuring out what our weighted ADM is. So remember what I said earlier. Weighted ADM comes in with some horizontal, but a lot of vertical equity as well. We have to pay everything in students. In other words, we know that it costs more money to educate a student who receives special education services. We know that it costs more money to educate children in lower elementary grade because class size is limited. We know that it costs more money to educate students in secondary school because teachers are specialized in their fields, and therefore we again need more teachers. And so we take all this into consideration, but we have to convert it to students. And so that's what this next piece is going to do, is show us how to convert all this into students. And we're going to work through each of these things on this chart to do it. And so the first thing we need to do then is we're going to start with our raw ADM and determine what our grade weights, our special education weights, our student weights, all these weights are, to come out with what our total weighted ADM is. Okay? So, in order to start, we need to look at this sheet. This is our raw ADM, weighted pupil grade level calculation. And you can see here that the chart here has how much we're giving for each student based on their grade. And so we pull the numbers from our data, and there we have our kindergarten through 12th grade and the number of students in each grade. And we plug those numbers in on the left. Okay, so we have 50 full-day kindergartners, 56 first graders, 54 second graders, and so on. Now we're going to push them over to the right, just like this, and then we're going to do some math. And so the first set of math here is we're simply going to total it up. So our you can see that these numbers that we're multiplying by are called grade factors. So when we have kindergarten, full day kindergarten, 50 students times 1.5, that's a 1.5 grade factor. So what we're doing is we're actually counting each student 1.5 times, so that 50 students has suddenly become 75 students. In first and second grade, we have 110 physical students, where we have a grade factor of 1.351, and when we multiply that out, we now have 148.61 students. So you can see what we're doing is we're converting these equity pieces into students. This is what I told you before we would do. Third grade is a little bit lower. Fourth through sixth grade, the factor is 1. It's pretty straightforward. And then when we get 7th through 12th grade, our factor jumps up slightly to 1.2. And this, again, is what we call vertical equity. So we tally up our total number of students, and down at the bottom you can see that our original raw ADM was 622, and our graded level weighted ADM is 740.86. Now, one thing that we have on here that I always have students ask about is that OHP 1, 2, 3, 4. These are out of school placements, and for all of our data, we're not going to use any of those out of school placements. So what we do then is find the difference between our original raw ADM and our grade level weighted ADM, and that difference is 118.86. And so when we go back to our original chart, we're going to input these two numbers. We're going to input our raw ADM as 622, and our grade weight is 118.86. And you're going to see in a second why that's really, really important that we're starting to do this. And we can add these together and we come out to 740.86. And that total weighted ADM is going to be a running total. So the next thing on our list then is special education weight. And actually what we're going to see is the worksheet that we're going to use has special education, gifted, bilingual, summer program, and economically disadvantaged all on the same sheet. And so let's look at that sheet now that we typically use just for special ed weights. And it looks like this. Weights for weighted pupil categories, okay? So that first one, let me go back, that 118 is grade weights. These are what we call pupil weights, okay? And you can see that we know we just have to plug in our numbers. So let's pull our numbers from our chart or our data. And you can see the numbers there, learning disability, hearing impairment, vision impairment, multi-handicap, and so forth. And when we get over here, we just simply put those numbers in. So now we see we have 32 students with a learning disability, 3 students with a hearing impairment, 2 students with a vision impairment. And what we're going to do is we're actually going to determine extra for these students, okay? So every student we have who's identified as a learning disability, we know it counts, it takes a little extra for these students, specifically because we're talking about hiring special education teachers who only have very limited students, and so on down the way here. And so you can see, and what we're going to do is provide extra student weights for these students. And you can go on down through there and see down at the bottom we have 49 students who are gifted. The idea is that we are doing something to enhance their education because they're gifted. In this particular district, we have no bilingual students, and we have 393 students who are economically disadvantaged or are receiving free and reduced lunch meals. Okay, sometimes I call these kids farm kids, free and reduced meals. So we have 393 farm kids. So we just simply do the math here, multiply it all across, and we get down to the bottom, and our special ed weight is 37.9, specifically special ed. But then when we add them all together, our total pupil weight category is 152.81. So we're going to pull these numbers off of this chart and transfer them over to the other side. So, and there they are. Okay. So our special ed weight, we said, was 3790, gifted 1666, and we're just transferring those numbers over. And you can see that we had no bilingual, no summer program, and our farm kids, our Title I kids, was 98.25. Now our total weighted ADM is up to 893.67. So now we're going to look at the small school weight versus isolation weight. And we're only going to choose one of these, whichever one is the greater of the two. And so we're going to determine these. And we're going to use one worksheet to determine each of these. Now, I will say that in general, most schools in Oklahoma don't receive either one of these. They get zeros on both of these. But just to let you see how it works and the philosophy behind it, let's look at this small school and isolation sheet. Now, this one is probably the most, by far, confusing just to look at it. But we need to pull some numbers off of our data. So let's go to our dummy data. We need our total square miles. Again, we're at 291. And we need our average daily membership at 622. We're also going to need to pull some numbers from our student weights. And this time we're looking at it a little bit differently. Okay, grades 1 through 5, grades 6 through 8, and grade 9 through 12. So we're looking at these numbers just a little bit differently. But you'll see what I'm talking about in just a second. So let's start at the top. Okay, so the first thing we're going to do is see if we have a small school district. So we start by simply plugging our numbers in. Up at the top left, raw ADM, 529 is the average size of a district. And so the first thing we do is we plug in our 622, our raw ADM. We subtract 529 minus 622 divided by 529, and we come out with negative 0.1758. Now, what you will see as we go through this is these calculations are typically taken to the fourth decimal, so keep that in mind as you work through it. The chances that you're going to get exactly the same calculations that I do as we work through the class are pretty slim. Okay, so if you're in the ballpark, that's fine. If we're off a little bit, that's fine. If we're off $1 million, then we're going to figure out something. Okay. But just note that it takes it to the fourth decimal, so that's what I encourage you to do. So one thing that we automatically know right offhand, looking at this, and I'm not a math person, but I know that once we put a negative number into a math problem, our answer is going to be negative. And anytime you have a negative answer, it's automatically zero as far as we're concerned. But let's go ahead and work the math here. So we figured our raw ADM, 529 minus 622, divided by 529, and that's a step, that division of 529 is one that's usually forgotten, so keep that in mind. We get negative 0.1758 times 0.2, negative 0.03516 times our same year raw ADM of 622. We get negative 21.86994, a little bit more than 4 spaces. But what I said earlier is that if it's a negative number, it's automatically zero. So we have no small school district weight. So now let's look for isolation weight. And so we're going to move down to the next part of the page, Part A, and let's just read through this, okay? If the school district's total area in square miles, and we're going to insert 291, is greater than the state average in square miles of 129, which it is, go to the next step and compute areal density. If the district has less than the average area in square miles, or less than 129, go to paragraph D at the end of the weighted district calculation. Now, if you go to paragraph D, that means you're automatically going to put 0 for the isolation weight. But since ours is greater than the average, we're going to see if there's an isolation factor here. So keep in mind what we're talking about. When we say small school, we're talking about low enrollment. Okay, because we know that, and the thinking behind this is small in the sense of low enrollment. If you have low enrollment, you still have to offer the same grade level, so you're going to still have the same grade teachers. And so if you have low enrollment, then this is to help that equity piece give you a little bit, because districts that have the average or more, in theory, they have enough students that are generating dollars through weighted ADM to pay for classroom teachers. But if you have low enrollment, let's say you only have 300 students in your whole district, then you're a small school, and you still have to pay those teachers the same whether they're teaching a class of 10 or a class of 30. And so that's where this would come into play. Okay. Isolation, on the other hand, deals with how spread out your district is in the terms of square miles. I mean, you know, we see isolation really out in the West with those districts that are upwards of 400 and 500 square miles within the district. And so we know it takes more to educate those students in the sense that this really gets into a little bit more philosophical stuff. But the idea is those students are isolated, and so the school needs to enhance and help supplement their access to information and technology at the school, because normally they're living in an isolated community. You know, and I was one of the students who grew up out in the country and was isolated from the rest of the world pretty much. But anyway, so let's go on. That's the thinking behind these two formulas here. So in A, we determined yes, it's greater than the average, so we're going to go to B and compute the areal density. And here what we do is the school district's raw ADM. Oh, I forgot. We said go to D. Well, there's D for you. And you would just put 0 if you skip down to D. But so back on B, we're going to compute the areal density here. So the school district's raw ADM is 622 divided by the district's total area in square miles. And we know that's 291. And so our areal density is 2.137. And so reading on the next one, if a school district's areal density is less than 2.21, calculate the district sparsity isolation formula as follows in the next step. If the district has an areal density of 2.21 or greater, proceed to paragraph D at the end of the weighted district calculation. And there's paragraph D, and we would simply put 0 there. Okay, but our areal density is less than 2.21, which means we have 2.137 students per square mile in our district, and that's less than our key number. And so we're going to go and do part C. This is where it gets a little bit confusing. It's easy to do, but just keep in mind, just follow the steps as they go. Okay. So here's where I told you earlier we need to pull those 3 numbers from our data. And just to give you an idea, we go back to our data and look. We're looking at the left, so all of our early childhood to 5th grade, 6th to 8th grade, and 9th to 12th grade. And we're pulling raw ADM. We don't want anything, the weighted stuff on the right. We just want our raw numbers. And so there are our raw numbers, and so we're going to input them throughout the chart. And you can see here that we have them up here at the top. I've plugged them in here. I've also plugged in our raw ADM here, and I've plugged in our district in square miles here. Okay, so now we're just going to do simple math and work through this. So 311 plus 23, 141 plus 133, 170 plus 128, and we get those numbers. Now we're going to pull these numbers, CA, CB, and CC, and we're going to come down here and work in the first 3 numbers here at the bottom. So we get 74 divided by 334 CA, 122 divided by 274 CB, and 292 divided by 298 CC. We pull our answers. They're going to be low. And then we add these factors here in plus our answers. And so now we're going to come out with some little bit higher numbers. And then we're going to multiply this times our raw ADM for these grade levels. And they're going to come out with these numbers. Okay. Now we're going to add these together. These are our cost factors. We're going to add them together. 81505. divide by the district's raw ADM of 622, 1.31. We're going to subtract 1 from it, and we're going to end up with a district cost factor of 0.31. Okay, 0.31. Now our areal factor, or area factor, is simply taking our district in square miles minus 129 and then dividing by 129. We come up with an area factor of 1.26. Okay, so we have two numbers, our district factor and our area factor. We're going to multiply the district factor, 0.31, by the lesser of the area factor, 1.26, or by 1. Well, here, we're going to pull 0.31 down. We're going to pull 1.26 over here. When we multiply it by the lesser, well, the lesser is 1. So our isolation factor is 0.31. Multiply the isolation factor on line 6, 0.31, times the raw ADM, 0.31 times 622, and our isolation weight is 192.82. Okay? So you will be able to figure this on your districts that you're going to work with. Just remember, you can come back to this page and work through it. And I would encourage you to draw these lines on here so you see where these numbers go as you're working down through the formula. So here was part D. We said sometimes we would skip part D, but we actually worked through C. So now it says, select the greater weight of the small school district weight or the isolation weight and use that weight for the weighted district weight. Well, we determined that our small school weight was 0 because we had a negative number. But our isolation weight was 192.82. So we're going to use 192.82 at the top, at part D, and we're going to drop the 0, the small school weight. So we're not necessarily a small school, it's just telling us that our school is somewhat isolated. And we plug the 192.82 into our total weighted ADM sheet, and our small school weight we leave blank. Remember, you can only have one of those numbers on your sheet, either the small school or the isolation weight. And our new updated weighted ADM is 1086.49. Okay? So now we only have one more thing to do, and that's to figure out our teacher index. And so with that, let's go to the last page that we haven't touched yet, and this is the weighted teacher index. Okay? So this is where you're going to pull the data dealing with your teachers. And here we have years of experience, a bachelor's, a master's, and a doctorate degree. Okay? So we're going to put those numbers into the categories where they go. And so you can see under here under experience, masters, we have 1 with 0, a first-year teacher, 4 who are in their second year, and so forth. And then when we get to 16 or more years, you just add those all together. And we're going to multiply by these factors at the top of each. So you can see we're carrying this out. And we're going to add up these two totals. Okay, so we have 17 actual teachers. Our degree index for master's degree is 18.8. So it's a little bit higher, which is normal. That's what you're going to see, typically, unless you have a lot of new teachers. We pull in our bachelor's teachers. And here you see our actual teachers is 33. But our degree index is 31.4. So this is a little bit lower. What this does is it takes into consideration the fact that if the school district has a very educated staff with degrees and lots of years of experience, it costs a little bit more to compensate those teachers. That's why this number is high. Now, we'll talk about a little bit about that later on when we get to the end of the state aid formula and how it would impact a school to lose a veteran teacher versus hiring a new teacher, and that kind of thing. Okay, so let's pull these numbers now. So this is our degree index. We're going to add them together, and we come up with 50.2. Then we're going to divide by our number of teachers, which is actually 50. So our degree index is slightly higher than what our actual teachers are. So when we divide those two numbers, we're going to come out with 1.0040. And here it specifically tells you to round to 4 places. We're going to subtract. So this paper is a little bit confusing. This is division. We get our weighted teacher index. We're going to subtract the school district teacher index. So this is minus the school district teacher index from 1.004. Well, our school teacher index is 1.1037. Okay, 1.1037. There's an extra decimal in there. I'm going to give you this number as well. Okay. I can't remember if I kept it the same or changed it, but I'm going to give you this number. And when we subtract those two, we're going to get our district teacher index of negative 0.0997. Now, we automatically know, since we see a negative there, that our answer is ultimately going to be 0. But let's carry out the math anyway. So once we divide our degree index by the number of teachers, subtract the school teacher index, we're going to multiply times 0.7. And then we're going to multiply by our grade weight and our economically disadvantaged weight. Actually, this is a little bit wrong here because our grade weight is actually only 118. So 118.86. So that number should not be that high. I just haven't corrected it on here. But it doesn't matter because we know it's a negative number, so therefore it's 0. But keep in mind, we're actually looking at just the grade weight, not the total weight. We're looking at the grade weight. And so I'll show you what I'm talking about here. So let's look at these two numbers, grade weight and economically disadvantaged. If we go back to our sheet, we can see our grade weight is actually only 118.86. Our economically disadvantaged is 98.25. But it doesn't matter because that number came out to a negative number, so it's 0. And so now we know that our total weighted ADM for our district is 1,086 students, 86.49 students. So we went from 622 students, and we calculated all those factors that we said were important in providing equity, and we added almost 500 students by doing that. So let's see what that does to our formula. So now we have this magic number of 1086.49. Let's go back to our chart and let's excuse me. Let's insert our weighted ADM. So we see it at the top, and now we can carry out our math. When we multiply our weighted ADM times our foundation aid factor, we see that our initial foundation aid factor, or foundation aid money, is 1.585 million. But we said that the district was able to generate almost $350,000 on its own, and so we have to subtract that from the state aid in the foundation aid factor, and it comes out that we have a foundation aid total of 1.24 million. Okay, so you see how that horizontal equity just happened right there in the top part of the formula. We already have our transportation factor determined, so now let's then move to I just explained this to you. We're subtracting what the district can generate on its own. So now we have the foundation aid factor determined. Let's move down to our salary incentive aid factor. And here we're going to take our weighted ADM again and multiply by 69.93, our incentive aid factor, and come out to 75,978. And we had already determined our adjusted district assessed valuation divided by 1,000. Step C tells us we're going to take A We're going to subtract B. So again, this is a little bit of equity here because we're subtracting what the district is able to generate on its own, a small percentage. And then step C tells us to multiply by 20 mils. Now this is a little bit confusing, and I don't know why they did this. This formula goes back to the 80s. And as we'll learn in our book, Oklahoma is one of just a few states that have this type of formula. Every state has a formula of some sort. But Oklahoma's, as far as an equity piece, is one of the few states that went in this direction. But in Part B, normally what we would do when we say we multiply by 20 mils, we would multiply by 0.02. But in Part B, when we divided this by 1,000, okay, we actually turned that into mils, and now we want to get it back into regular dollars. And so instead of actually multiplying by 20 mils, we're going to multiply by 20. And so when we take 71,000 times 20, we come out to 1.437 million. Okay, now I know that's probably a little bit confusing, but just keep in mind in Part C, when it says to multiply by 20 mils, we're actually just multiplying by 20. And the reason that we're not doing the mils, again, is because we had already converted this to the thousandths base up here in Part B. So next, the last thing we're going to do simply is add our three totals together. So take our foundation aid, our transportation aid, and our salary incentive aid, add them together, and our district of 622 students is going to receive $2,728,625.49 from the state for this school year. Okay? So that's not too terribly confusing, I think. Anyway, over the next few weeks, you will be working through this, and I will be around to help as questions arise. So please feel free to reach out to me if you have any questions.